The first time that we've got an x in there. So the n is going from 0 to infinity. But we've also got this value of x, and we're supposed to solve for x. Well, if you look at this, if the x wasn't there, it's 2 to the n over 2 to the n. That means you need to add up 1 plus 1 plus 1 plus 1. That will diverge. That adds up to infinity. So that means that the numerator actually needs to be something less than 2. For example, I said less than 2. For example, if x was equal to a negative 1, then that would create a 1 in the numerator. So it would be 1 over 2 to the n. That's a geometric series. And since it's 1 over 2, that's less than 1, so it converges. Or in other words, this whole thing is really one big geometric series. You could rewrite it as the whole thing is raised to the n, and then it's a fraction x plus 2 over 2. So it's a geometric series with the r equal to x plus 2 over 2. The rule for a geometric series is that it will converge if the r is less than 1, and in absolute value, because it could be positive or negative. So we say the absolute value of x plus 2 over 2 has to be less than 1. Now solve this absolute value inequality. So take x plus 2 over 2 and sandwich it between a negative 1 and a positive 1. So multiply by 2, subtract 2 from every side, so this is going to become a negative 4. Subtract 2, this is 0. So then, for numbers between negative 4 and 0, so for example, negative 3. So if you put a negative 3 in here, then that causes a negative 1. So in the numerator, you would have a negative 1 over 2. So again, it's essentially a half. Then it's going to converge because it's a geometric series less than 1. You might think, well, wait a second, won't the negative mess it up? Well, if this series converges, which we know it does, then this series is actually going to add up to less, because this is saying take a half plus a quarter plus an eighth plus a 16th, etc., add those up. Well, when this is an even power, you're going to get that half and quarter and 16th, eighth and 16th, etc. But when this is an odd power, it's going to subtract. So actually this is going to add up to less than this. And if we know this adds up to some finite number, then this is even less than that, whatever that answer is. Then when you get an interval like this, it's usually a good idea to check the endpoints to see, is this really supposed to be equals or not equals? I mean, are we supposed to have less than or equal or not? So check, if you put 0 in for x, or 0 in for x, then that's going to be 2 over 2. So that means you add up 1 plus 1 plus 1 plus 1. No, that does not converge. How about if you put a negative 4? Put negative 4, then that's going to be negative 2 in the numerator. Negative 2 divided by positive 2. That means we've got the sum of negative 1 to the n. So take negative 1 and positive 1, negative 1 and positive 1, negative 1 and positive 1, and add them up. Does that converge? Well, this one starts at n equals 0. So if you put a 0, that's a positive 1, and a negative 1, a positive 1, and negative 1, a positive 1, and negative 1, and it keeps going forever. Does it converge? Well, there's a couple of ways to look at it. One is you pair up the numbers this way, and you get 0 plus 0 plus 0 plus 0. The answer is 0. But the next person comes along and says, yeah, I want to pair up numbers. I've got a 0 plus a 0 plus a 0 plus a 0 forever. The answer is 1. So depending on how you pair these, one person could get the answer 0, the other person could get the answer 1, and so if it doesn't have one single answer, it diverges. So it turns out our interval is just fine the way it is, don't include either of those.